First of all, I want to introduce your presenter today. Daniel Villani is the solution architect for our New York market. He is a member of our enterprise performance management practice and has extensive experience implementing EPM, BI, and ETL data warehousing solutions for our clients in a variety of industries. Daniel has published various articles as well as presented on the topic of enterprise performance management architect at events like Kscope, as well as other Oracle user group events. In terms of a brief overview on Peloton, we are a services firm that's specifically focused on EPM, business analytics, and information management. And through our advisory, implementation, outsourced services, we do assist our clients in specific areas such as business planning, consolidations, and financial reporting, as well as analytics, data integration, and infrastructure. We deliver value for our clients, first and foremost, through our business and IT professionals who bring both business process improvement and technical implementation expertise, as well as our collaborative implementation methodologies that drive end-user adoption. With that, Daniel, before we dive into specific tips and tricks of EPMA, can you walk us through an overview of EPMA to help set the stage and highlight why and when EPMA is a tool worthwhile considering?
Absolutely. Thanks, Ray. Just wanted to say welcome for everybody who is joining us today. Appreciate you taking the time out of your schedule. So first, what we're going to do to make sure everyone's on the same page in terms of what EPMA is before we jump into the implementation tips and tricks, we'll just provide a little overview of it. So I like to give an overview in the context of a solution. So let's just assume for a second that we have two applications, a planning application and an Essbase archive application. If we look at the dimensions that are in each application, we're going to notice that they're very similar. The only difference is going to be the number of years that each application has. So the planning app will be mostly current data, whereas the archive will be historical data. So if we look at this in terms of how we would build it, we have a data warehouse or flat file, the source of our metadata, and then we have our target applications. So one thing to note is that how we build these applications differs based on the application type. For example, our application 1 is a planning application. So what we would need to do is define our hierarchies in terms of planning properties and create either an outline load utility process or use Oracle Data Integrator in order to bring that metadata into our application. For the archive, if that's just a historical Essbase cube, then we're going to need to create a second process because our planning application and Essbase application are built two different ways. For Essbase, you can build your dimensions with load rules or ODI. However, how we designate the properties differs between the applications. For example, if we want to designate a member as stored, in Essbase it's going to be a single character depiction of that as an S. In planning, it's going to be store. So what we'll need to watch out for is the different ways that we need to build each of these applications. So when we look at this in terms of maintenance, we notice that our maintenance is scattered between our source, and our integration layer in the middle here, highlighted in red, and our applications. So because we have the maintenance that's scattered in three different places, it becomes difficult to manage, and it doesn't scale very well. If we were to add 3 more applications to this, we would have to build 3 more processes to load and manage that metadata in there. So as we look for better ways of doing it, we can use a tool such as EPMA to simplify our maintenance and make our solutions that much better. So if we look at the same source, we no longer have to define our properties in Essbase and planning notation. We can define them in EPMA notation and create an import profile to import them into a shared or centralized library where we can maintain the dimensions in one place and drag and drop them into our applications. And you can drag and drop into Essbase, Planning, HFM, or HPCM. So if you have any application of each of those types, you just need to define your metadata once, and you can drag and drop it in as many different application types as you want. And then you can just deploy the application to push the metadata back into the outline of that application. So for example, our account, department, scenario, version, and period, those are the same between our two applications. Those aren't going to change. So we can drag and drop, designate them as shared, and then deploy it to our application. The years dimension is going to be different between the two applications. Our planning application is going to be mostly forward-looking, while our historical Essbase cube is going to be prior years. So what we can do is we can create local dimensions within each application and specify which years we want to bring in. So we can bring in different years to different applications, and when we run our deploy, that's going to get all pushed down to the outline. So if we look in terms of what are the benefits of doing it this way, we see there's now reduced maintenance. We don't have that layer in the middle for the integration processes with the outline load utility, with ODI, with load rules. We manage our dimensions in our source, in our data warehouse, and in our shared library. We don't have to worry about a ton of in-between manipulations that need to take place. We also have flexibility with EPMA. We can define our hierarchies in a data warehouse. We can define them in a flat file, such as an Excel file. We can define them in Oracle's DRM tool. So new to version 11.122 and going forward, DRM now integrates directly with EPMA. And you can define your hierarchies directly within the shared library itself. So if you define your hierarchies in DRM or the shared library, you don't need to create any ETL processes. You don't need to create any tables in between your source and the shared library. You can define them directly within the tool itself. And in terms of scalability of the solutions, if we think back to the previous slide where if we needed to add 3 more applications down the line, we needed to create 3 more processes. Well, we don't have to do that with EPMA. We can create as many applications as we want, and we can reuse these dimensions as many times as we want. So it creates a scalable solution that you can reuse over and over again.
Thank you, Daniel. That's a really good overview. Now, from plenty of experience implementing EPMA in various projects, you know, there's always lots of lessons learned and tips and tricks in how to implement, you know, and leverage the various tools that are out there. You know, the remainder of the presentation would be great if you know, let's walk through some of those tips and tricks and share those with the audience.
Absolutely. Thanks, Ray. So if we jump into the tips and tricks portion, we'll start with interface tables. So as I mentioned before, there are many different ways to define our dimensions. What we're going to focus on for this presentation will be the dimensions defined in your interface tables or within those relational tables that get pushed to the shared library. So this can be an easy way if we define through interface tables to maintain the dimensions automatically, because you can put in additional logic to do any types of conversions that you are looking for. So interface tables are dimensions that are defined within physical tables. And it's, like I said, it's easy to dynamically build and update your hierarchies. And you can use this for automatic refreshes of metadata from your data warehouse. There's a table that gets used called IMDimension, and that points to the interface tables. So if we look at our 2 diagrams on this slide, the top one is an example of what an interface table would look like in terms of definition. This is for a scenario dimension. And in the picture on the bottom of the screen, you'll see this is what the role of that IMDimension table is. So this is a table that gets created within Workspace, and it's used to be the middle kind of the bridge table between your shared library and the data warehouse. So each of your dimensions in your shared library on the left talk to this IM dimension table when you run your import processes, and it does a lookup. It says, okay, I'm going to update my account dimension. What physical data warehouse table does that point to? And then it goes to that table and pulls the definition of your hierarchy from there. So that table is very important in terms of the role that it plays in being able to update your dimensions. For your interface tables, one thing that makes maintenance very easy is to keep your column names consistent with what the EPMA property is. So EPMA automatically maps the columns in your interface table to the EPMA property based on the name. So if the name of your column matches exactly with the EPMA property value, then when you're creating your import profiles, it's automatically going to map the column name to the EPMA property. So for example, for data storage, if you name it data storage, just like it is in this diagram here, when you create your import profile, it's going to see that column that says data storage, and it's automatically going to know, oh, this is the EPMA property for the data storage. So we have a couple of common column names that you would be using when creating interface tables. So this can result in huge time savings over spending the time to manually map the properties. So it's just a good way to ease some of the maintenance and make it a little bit easier for the developer. Another thing to note is what I talked a little bit about on a previous slide was the difference between how Essbase properties and planning properties are depicted. So for example, data storage, you see that label only is an O in Essbase, and planning has label space only. You don't have to worry about which value to use when you're using EPMA, because EPMA has its own depiction of what label only is, what store is, what dynamic calc is, what never share is, and so forth. So this way you can define your properties in one language, the EPMA language, and it can automatically get converted to each of your different applications based on the type. So you don't have to worry about manually doing conversions and putting it in whatever format it needs for that particular tool. One issue that we've run into is with the time balance property. So something to note is that in Essbase, time balance last is depicted by an L and it's last, but in planning it's referred to as balance. So when you're defining any particular members that have time balance associated with them, you'll just need to watch out for this, that if you're building Essbase applications, you're going to refer to it as time balance last. When building a planning application, you're going to refer to it as time balance balance. And then in the event that you need to convert back and forth between Essbase values, planning values, and EPMA values, it might be helpful to create a lookup table so that way you can automatically convert back and forth without any additional maintenance required. So another thing that comes up is in creating shared members. So if you read through the documentation, you'll see that creating shared members is very easy. You just designate a member with a data storage property of shared data. But shared data actually doesn't exist when building with interface tables. So just watch out for the references in the documentation. The correct way to do it is to set your alias equal to null, your data storage property equal to null, and to use a column called isPrimary, which is going to determine whether your member is the main member in the hierarchy or a shared member in the hierarchy. So any main members in the hierarchy will have isPrimary of 1, and anything that's shared will have an isPrimary value of 0, like you can see in the highlighted rows in this table. Another thing that comes up a lot is that many of our clients ask us, well, what if I have an ASO application and a BSO application? Do I need to create two different hierarchies to account for things like the member formulas between them? Do I need to create manual overrides on every single member to have what the ASO value is and what the BSO value is? But EPMA makes this very easy. So it gives you the flexibility where you can define for a given member what the ASO formula is going to be and what the BSO formula will be. So if you look at this table at the bottom over here, you'll see that on one member I have the MDX formula for this AC variance, and for the BSO formula I have that in the regular Essbase BSO syntax. So now I can define this flexibly so that if I bring this hierarchy into an ASO cube, it will use the MDX formula for it, whereas if I bring it into a BSO cube, it'll automatically use the BSO formula for it. So it's just very easy and allows you to create one hierarchy and drag and drop it between ASO applications and BSO applications. So next we'll look at some of the tips and tricks regarding EPMA's shared library. So the EPMA shared library is great because you can create shared or reusable dimensions, and it gives you the capability to build a dimension once and deploy it anywhere or everywhere if you choose. And you can just drag and drop dimensions to your applications, and all your shared dimensions that you've designated will automatically be synchronized to the application when you run a deploy command. And you have the flexibility to create application-specific dimensions in the event that you don't want them to be synchronized. If you have a dimension that only applies to one particular application and you don't want to share it with other ones, you can specify it as local, and it will only take effect for that application. In terms of dimension setup, one thing that we always recommend is to share your dimensions, designate them as shared between applications that are going to have similar dimensionality. That way, any changes that you make will automatically push through when you run your deploy commands, and you don't have to worry about, do I need to run the process for this and that? You know, you can just run one process and push it to each of your applications. And if you have any application-specific dimensions that you don't want to share across applications, you can designate those as local so that you don't have to worry about if you make a change in one application, is it going to affect another one. And there are tags that specify whether a member is valid for a certain plan type. So you can use those tags to control your hierarchy so that certain members only go to one plan type, whereas others go to another plan type. And in the event that you are using multiple hierarchies of the same dimension type, so if you have two account dimensions, it can be helpful to use naming conventions to distinguish which one it is, so that if you have one dimension that's called account 1 and the other one that's called account 2, you don't have to worry about, well, which one is which one am I using. If you use a naming convention, you can easily distinguish between which is which. Another thing that needs to be done when creating attributes and aliases is that in EPMA you have to create attributes and aliases as separate dimensions and associate them with the hierarchy that they pertain to. So you may be familiar with doing this for attributes, but aliases is another thing that has to be done, where you have to create an alias dimension and associate your alias properties to that dimension. So when creating shared and local and trying to figure out which one should I use, should I designate this as shared, should I designate this as local, try to plan ahead to see which ones you anticipate that you're going to use and create those within your shared library so that you can easily drag and drop between them. And if you're not sure, we have a little crystal ball over here that you can look into, and it'll specify, it'll tell you which is the right way to designate it. With EPMA dimensions, you have the ability to perform manual overrides. So if you have a hierarchy where you have something like, for example, in this case, we have an alias that we want to change in one application, but we don't want that change replicating through to all applications where this is designated as shared. You can perform a manual override in the application where you want to make the change, and it won't automatically push through to the other applications. So manual overrides are designated with the little icon down here that has the red box around it. It's a picture of a person's face, and if you see that icon, it means that any changes that you make to the shared library for that particular property are not going to be updated automatically. So if you change the alias in your shared library and you want it to take effect in this application, by default, after you've performed a manual override, it's not going to automatically update this alias to what you changed it to. So just be careful when you're doing manual overrides and make sure that you take note of which ones that you're doing so that in the event that you do make a change, you know where it will and where it won't take effect. And if you do have a manual override on a particular property or member, if you want to remove it, you can easily remove it by right-clicking and selecting Clear Property Overrides. And what that's going to do is that's going to remove any overrides that you have. And the Clear Property Overrides is contextual, so if you click on the dimension level, you right-click and do Clear Property Overrides, it's going to clear them for every member within that dimension. If you do a clear at the application level, it's going to clear every override you have in every dimension for that application. So just use caution when you're clearing the overrides and make sure that you're clearing them at the appropriate level, because if you clear them at the application level, it might reset your performance settings, the outline order of your application, and when you try to deploy it, it'll give you an error and say you have to reset your performance settings. So next we're going to talk about EPMA application deployment. So one thing that I always recommend is to always create your dimensions in your dimension library first, and then create your application second. And the reason why we do this is because when you're creating your application, if you have shared dimensions that in your application, in your dimension library that you want to bring in, you can do that from within the application wizard. Whereas if you create your application first, then you have to create it with generic dimensions and then replace them all. So it'll save a lot of time if you just create the dimensions first and then the application second, and you can create the associate shared dimensions with your application. So it'll save you a lot of time if you just do it in that order. When deploying your application, sometimes your job seems to fail for no reason. And if you run the deploy a second time, it'll succeed. So in the event that you have a job that seems to fail for no reason and you look at the logs and it looks like everything is fine and you don't know what happened, try rerunning it a second time, because if it succeeds at the second time, then it's just a little quirk within the tool. So if at first you don't succeed, try it again. In terms of performance settings, whenever you go to deploy an application, you should always check the performance settings within the application, just because sometimes they get reset if you're clearing property overrides, when you're changing some dimensions to dense or sparse, if you add dimensions to your application, and if you remove dimensions. Those performance settings will try to guess what the optimal one is, and when you go to deploy it, it'll fail and it'll tell you to check your performance settings. So EPMA won't let you run a deploy if all your dense dimensions aren't before your sparse ones. So if you have a dense dimension and then a sparse one in the second order, and then your third order is another dense dimension, it'll fail and tell you to check the performance settings. It won't let you deploy it until you put your dense dimensions first in the outline, followed by your sparse dimensions. So always make sure you check the settings before you do a deploy, just in the event that something gets reset. It'll cause an error, and you'll have to go in and change the performance settings. Now that we've gone through the interface tables, the shared library, and the application deployment, we'll talk a little bit about how do you automate EPMA jobs. So we'll talk about the EPMA-Batch client and how it can be used to ease maintenance and make things a little bit more streamlined. So just to give you a little overview of the EPMA-Batch client, the EPMA-Batch client allows you to create automated EPMA jobs. So you can do things like running your import profiles to pull your dimensions in from your source definition to the shared library. And you can also use the EPMA-Batch client to redeploy your applications. So what you can do is create a script that brings in your dimensions from your source to your shared library, and then redeploy all applications that are designating that dimension as shared, and that way you can keep everything in sync. And it's invoked through batch scripts. So the benefit of building batch scripts to do all this is that you can create automated logging and error handling, so that way you don't have to constantly be clicking in your job console and viewing each of the logs one at a time. You can go through your script, have it create one log that has everything in it, and you can just go and check one file at the end. And if you're using the batch client with command files, you can create a text file, as you can see in the image in the lower left over here, where you create this command file, and that tells the batch client what commands to execute. So this is an example down here of running an import profile, and each of the items that are required in order to do that. In terms of batch client automation, there's limited parameterization when using the command files because they're text files. So it becomes difficult to pass in your usernames, passwords, and links when using the command text files. So sometimes if this is something that needs to be automated, an additional batch process might be needed where you create a batch script that first writes that command file and then executes it, and that way you'll have an automated solution that's driven off of parameters and environment files. And then just one other thing to note about the batch user is that you need to have a user that has the EPMA administrator privileges within Oracle Shared Services so that you can run your import profiles and your deploy commands. If you don't have that access, then it's going to fail and not let you run your import profiles or run the deploys. And we usually recommend that when using an automated process that you create a separate user for an EPMA-Batch user to monitor when it's going in the system and what it's doing. And another reason for that is around the batch user's password. So when creating your batch scripts, it's very important that you avoid using special characters in the password of the user that's running the jobs. So many of you might have Active Directory systems where you restrict passwords and you make sure that they're secure passwords with a letter, number, and special character. If the batch user has a special character in its password, it'll give you errors when trying to connect and run your batch processes, and it'll give you some connection error that won't be specific to why it's failing. So just to avoid all those headaches, you should create a separate EPMA-Batch user as a native user so that you can create a simple password that doesn't have special characters in it and you don't run into any of these issues. Just moving to the next section, we'll talk about Calculation Manager. So just to provide you with an overview of Calculation Manager, as of version 11.122 and going forward, Calculation Manager is now the default way of creating business rules. So it replaces those EAS business rules that have been used prior to version 11.122. It's accessible through Workspace, so you can just go on the web and go to Calculation Manager by logging into Workspace and going to Navigate, Administer Calculation Manager. And it allows you to create business rules that are graphical. So we'll walk through a sample graphical business rule in the coming slides. You can also use the default script view that many of you are used to when creating the business rules in EAS or creating an Essbase calculation script. And it also allows you to create reusable templates so that you can create generic and dynamic code and reuse it from between multiple business rules. Some things to note, some of the differences between a calculation manager rule versus a regular business rule is one of them is the runtime prompt syntax. So if you create business rules within EAS, you reference runtime prompts with the brackets. In Calculation Manager, you're going to use the set brackets instead, and that's how you reference any variables and runtime prompts that you are using. Another distinction between the two is that in Calculation Manager, every time you create a rule or modify it, you need to deploy that rule for it to take effect in all the applications that it's being used. So in the event that you decide to change a business rule and go and run it within your application, it's going to run the old code until you deploy that rule to your application. And just talking about security around your rules, once you deploy the business rule to your application, the security is managed in the application itself. So you go to Administration, Manage Business Rule Security, and that way you can manage that rule on an application-by-application basis. So it gives you the flexibility where you can create the rule, push it to multiple applications, and manage that security separately for it on who can launch it and who can not.
We just got a question from the audience on, I think, those particular items. I figured I'd insert those before we move on here. For Calculation Manager, do you see a downside in deploying everything all at once, or would you recommend selectively deploying items and going through that process?
That's a great question. I typically deploy them one at a time, like just the ones that change. It's perfectly fine to deploy them all at once. What I've always noticed is that with Calculation Manager, when you go to run if it's something that's not associated with a form, if it's just an on-demand rule, the list of business rules that you see comes in the order in which those rules were deployed. So if you deploy them all at once, you might get lost and not know where the rule is. Versus if you just make a modification to one rule and you deploy that, it's going to be on the last page, the last thing you see, so you know exactly where to go to run it. But it doesn't matter which, if you deploy them all at once or one at a time.
Great, thank you.
Okay, so if we go to the graphical interface of Calculation Manager, we can see that there are 4 main components to a graphical business rule. If we start in the upper right in this pink section over here, we can see that this is a graphical view of your rule. So this is all the steps and components that you're using. So in this case, we have some conditions, we have some scripts, we have a member block, another script, and then we have an ag rule at the end. And we have the ability of invoking one business rule from within another one. So if you can see at the end here, what we did in this script was we created some standalone scripts and we created one generic ag rule. and that ag rule is called at the end of this. So it runs through all the code here and then calls our generic ag rule where we wrote one rule and we're bringing it into each script. So just from a maintenance standpoint, if anything changes in the ag itself, we don't have to redeploy. We don't have to go into every single script and go and make the change to the aggregation rule. We just change the source, the underlying rule itself, and then it's automatically going to take effect in all rules that call it once we redeploy them. In the green section over here, we have the objects for the graphical interface. So there are some generic objects. There are formulas, there are scripts, conditions, member blocks, member ranges, and fixed loops. I typically don't create rules that have all different types of this, but what I do is the ones that I typically use the most are scripts and the member ranges, and I use those to create generic code that can be called from within other rules. So it's a great way to help reduce the maintenance of your scripts. In the event that you want to do something like what I did here, where I created one generic ag and I'm calling it from multiple scripts, you can go into the section that's highlighted in blue over here, and you can go into any application and drag in an already created rule that you have. So you can just take that, drag it in, put it anywhere that you want in the chain of the logic, and so in this case we put it at the end. Once we run through all our logic, it calls the ag. And what's highlighted in yellow here is probably the area that you're most familiar with. This is where you actually type in your code and your scripts that you create. So just thinking in terms of, you know, the pros and cons of creating graphical rules, the benefits are that you have something that's graphical. It's easy to see each of the steps, what each of them is doing. You can drag and drop pieces wherever you'd like, and you can create reusable code and templates where it eases maintenance a bit, and you don't have to go and make changes everywhere in the event that one little thing changes, such as an ag. And you can create different steps. So if you're someone who likes to program out your rules in individual sections and steps, and that's how you like to see it, you have that flexibility where you can create a step for everything that it's doing, and that way if something is off, if one step is off, you can go directly to that individual step and modify the code there. And just on the, the con side, is it worth it? I mean, it can be a little bit slower to create rules like this instead of just putting it all in one script. And you have code all over the place, so if you don't know exactly which step was it that broke, you might have to go in between multiple steps to find where the error is. And just because of that, it can be a little bit difficult to maintain, but it gives you the flexibility of creating generic and reusable code. So you can either look at it as it's difficult to maintain with multiple steps, or creating the multiple steps might help you ease maintenance by reusing bits and pieces of code. So if you're on a previous version of Calculation Manager, 11.121 or earlier, it's certainly a good time to consider upgrading to the latest version, 11.123. And just because there are significant improvements that have been made to Calculation Manager as well as to EPMA itself. So for example, now when you're writing Calculation Manager rules, you can have line numbers, which you can toggle on and off. If you don't want to see them, you can turn it off. If you'd like to see them, you can turn it on. And it's very helpful from a coding standpoint, because when you get those errors that say error on line 127, you don't have to go down and count 127 lines till you see what your error is. You can just easily scroll down till you see the line number that has the error and make the change there. There's also improved syntax highlighting. So if you're typing something in there like a fixed statement as we have down here, or the is MBR. When in the older versions, whenever you type something in order to see the syntax highlight in blue, or if it's a comment green, or any other color, you need to save the rule, and then it'll show you the color coding on everything. With the newer versions, when you save it, or if you just press the space bar to go to the next piece, it'll automatically highlight the syntax for you, so you don't have to save it every time you type something in to see if that's a valid command. There's also syntax completion, which you can turn on and off. And this is great because if you're someone who types in fixed statements and if logic, and you have nested if logic and things that have multiple parentheses, when you open the parenthesis, it's automatically going to create the closed one for you. Also, when you open quotation marks, it's going to close the quotation mark for you. That way you don't have to worry about, do I have 6 open parentheses and only 5 closed parentheses. To troubleshoot things like that can take a long time. So if you use the syntax completion, you don't have to worry about, if I open a parenthesis, am I going to remember to close it at the end? Another thing that always bothered me was when using subvar names and you're copying a subvar name from one script into another, it would never copy in the previous versions. It would never let you copy just an individual subvar name. If you had a range like what we have here from current year to forecast year 10, it would copy up to the colon and then not copy the second piece of it. This is something that was fixed in the current versions, so you don't have to worry about any issues arising from copying and pasting the subvars. And there's also upgraded error reporting on here, so it's come a long way from where it was in the previous versions in what errors it catches. So it's definitely a good thing to think about if you're considering upgrading to a new version. So the last piece of what we're going to talk through today is around, well, now I've created all my EPMA components in my development environment. How do I get them up to my test environment? How do I get them up to my production environment? So we're going to talk a little bit about some of the issues that might arise in your migration process. So when moving from your development environment up to your production environment, most components can easily be migrated. So calculation manager rules, your application properties, your settings, your local dimensions, as well as your shared library, and your import profiles. Those can all be easily migrated. The calculation manager variables and runtime prompts that you create, sometimes there are issues when you're migrating them using Oracle's LCM tool. There is another way to do the migration of your calculation manager rules, and that's through calculation manager itself. So within the interface, you can highlight your rules and right-click on them and say export, and it'll export as an XML file the definition of the rules, as well as any variables or runtime prompts that are used in that rule. So in the event that you do an LCM migration and you don't see your variables or runtime prompts coming through, you don't have to go and manually create all of them by hand. You can do an export and import within Calculation Manager, and then you'll be able to get all of the variables and runtime prompts. On this next slide here, this is a fun issue because you see that there's like 1,000 lines within LCM, and it seems to tell you absolutely nothing. So what to watch out for if you're creating any of your dimensions using the interface tables, that LCM does a check before it actually does the import, where it checks to see, is there a connection to that IM dimension table, and is it populated? So if you're trying to migrate import profiles and you haven't set up that IM dimension table where it doesn't exist yet in your test environment or your production environment, or if you have it there but didn't populate it with all the pointers to which tables, then it's going to fail and it's going to give you this extremely cryptic message, and you won't be able to figure out what it's pointing to. So when migrating, always migrate your underlying interface tables first, then migrate the import profiles, and then you can migrate your dimensions, and everything will be okay, and it won't give you this error message. So we've reached the end of our portion of the tips and tricks and going through what EPMA is.
What I would recommend is that everyone does submit their questions either through the GoToWebinar tool here or through email. With that, I want to thank everyone for your participation. Thank you very much, and have a good day.